Very good evening, everyone. So our today's topic of discussion is linear versus logistics regression. So first, we will need to understand that what exactly is the technical difference between these two concepts which being used in the regression strategies in machine learning. So first of all, we will see what is a linear regression. So generally, whenever we have a particular target variable which is continuous in nature and exploring a linear relationship between the input and output, then generally the idea is known as the linear regression. Like if you see this particular formula, which is representing a straight line, where the value of y is the predicted one and the nature is continuous. And we do have the independent variables over here, as you can see, like x1, x2, xn, these are all independent variables. And beta 0, beta 1, beta 2 are different coefficient, which is also known as weight. And epsilon is one of the error function. And this is basically the equation, a straight line equation, a linear equation, which is used for any type of linear regression related problem. So any specific characteristics, if you would like to example, like say for the house price, whenever you start predicting, we make use of the linear regression strategies. And generally, the linearity is one of the core idea behind the linear regression. From the name, it is very clear that uh, a really linear relationship has been explored between the input variables, input features, and the corresponding target value. We'll also see with an example in Python that how the idea of linear regression is actually incorporated. One most important error is associated with the regression strategy, which we have discussed earlier. That's called mean square error. So the main strategy behind linear regression is to minimize the loss function as much as possible. So that's basically what exactly we call it as the linear regression. And these are the core characteristics of a linear example is predicting a house price of any particular city. Now, at the same point of time, if I consider logistic regression, so as I already told you, that the name is regression, but actually it is used for any type of classification related problem, any type of binary or multi-class classification. Whenever you are doing, we make use of logistic regression. And this is the formula of logistic regression. As you can see, we start finding out a probability. So here, the linearity has been transformed into a probabilistic representation with the help of one very popular function that's basically known as the sigmoid function, which looks like in S. So I have made one separate video on logistics regression using sigmoid function. So all of you can check that to understand the basic idea behind logistics regression. Now coming to the discussion that what exactly is the core difference between linear regression and logistics regression. As you can see here, like predicting the price of house can be an example of a linear regression, wherever if I consider that what exactly is the probability that a customer will purchase one specific house, then here the problem becomes a logistics regression, which can be represented with yes or no, or we can say with 1 or 0. So that's what is known as a binary type of problem. So if you look at this particular equation, so you can understand that yes, it is nothing but finding out a specific probability of the positive class. And the most important role being played in logistics regression is the sigmoid function, which is giving us an assurance that yes, the probability is always in between 0 to 1. There are some core characteristics of logistics regression. As you can see over here, that the probability always lying between 0 to 1 and the threshold represented as 0.5, which is determining the final class level. Like say, for example, whether your decision is positive or negative, which is actually depending on the value of a specific threshold. But the probability value always ranging in between 0 to 1. So non-linearity is one of the core characteristics of logistics regression, whereas linearity is the core characteristics of a linear regression. So here also our main intention is to minimize a loss, but here the loss function is little different, which is basically known as a log loss function we use in logistics regression. So if you'd like to see that when basically we will make use of linear regression and when to make use of a logistics regression. So suppose if we are considering any specific target value variable and which is continuous in nature, like say, for example, sales price or the price of a house, we generally make use of linear regression. Wherever the target variable, if it is binary in nature or if it is categorical, then obviously we will consider it as a logistics regression. Like say, for example, email, whether it is a spam email or a regular email, if you would like to detect, or whether a customer is interested in purchasing a house or not. So we generally make use of logistics regression. So there are various ways we generally make use of logistics regression. So if you see, starting from the beginning, what we have already discussed, let me recap before we move into an example. So this is what exactly is the definition of linear regression, which is basically used where the target variable is continuous. And this is one of the example, like predicting the price of a house. And linearity is the core idea behind the linear regression. Whereas if we consider logistics regression, where the binary problems or a multi-class classification problem generally resolved with the help of a logistics regression, where the value is always outcome of a specific probability, and sigmoid function is playing a significant role, as you can see from the formula itself. And it's always ranging between 0 to 1, where threshold has been taken as 0.5. So this is what exactly is the core difference between linear and logistics regression. Now let's take one example using Python Jupyter Notebook to get the clear idea behind this particular type of functions. Basically, we are using for linear regression as well as for a logistics regression. So we will now consider one specific example using Python Jupyter Notebook to understand the core difference, that what type of package basically we need to make use whenever we are actually talking about the linear regression as well as the logistics regression. Okay, so let's focus on a specific example now. We will have a look on a specific example on Python Jupyter Notebook. As you can see in this particular example, we have used a specific package from scikit-learn model, which is linear regression. And here we have taken certain sample data. We have represented that in the form of an array. And as you can see, this is basically the square feet of the house. And we have also considered the price associated of the house. So my main intention over is to find out predict the price of a specific house based on certain new data. And we have called the corresponding method, as you can see, the linear regression with a corresponding fit function. And ultimately, we have taken a new value 2000, which is not a part of our data set. And we would like to predict the price of the house where the size is 2000 square feet. And as you can see that this is what exactly we have received in the outcome, the price of the house where size is 2000 square feet. So this is a common example for linear regression, and you can understand that predicting the house price was the core business requirement over here. Whereas if you have a look on the second problem, which is solved using a logistics regression, and like linear regression, here we have imported logistics regression from the scikit-learn package, and we have considered a little different data set, because here our main intention is to find out the decision of the buyer, whether the buyer is going to purchase the house or not. And for that, we have taken a specific list of arrays. As you can see, the income range, first array is representing the income range, second is representing the decisions. And here we have taken a specific logistics regression value. And finally, what exactly we are doing? We are predicting the price of a specific house where we have taken a new data. And this is what exactly is my new data, which is not available in the corresponding data set, as you can see. And we have already received an output that what is the probability of the buyer with a salary of $47,000 to purchase the house. And we can say that the decision is 1. It means it's a positive decision. So if you see these two examples, which is giving you a very clear idea between that what is linear regression, how we can implement using a Python Jupyter notebook, what are the models which we need to import, and at the same point of time for logistics regression, what type of problem basically we can solve. Thank you so much for watching the video.